See, we have a full crowd today. Let's get started. Good afternoon, everyone. My name is Eddie Fong. I'm a group program manager in the Exchange Online team. I'm incredibly excited to talk to you about how we run our services online. I will also be inviting a few of my coworkers to join us on stage to tell you our story. First of all, super clear, we are a bunch of engineers. Engineers that make mistakes, learn as much as we can from them, and you will hear and see how we deal with sort of the chaos that sometimes come from running a global service. In fact, as you will notice, our data centers do not look like this, even though marketing may want you to believe so. What we will show you, though, are real pictures and things such as us loading servers into our data center, and then occasionally, when we make mistakes, pictures like this. We are going to show you stuff, data, metrics, that are unique to us running the Exchange service. In fact, we'll talk about stories that are very authentic and transparent. But as the slide says, we are trying to be careful about what we will show. And in some cases, we're going to take out data, facts, and other numbers that in some cases are going to be wrong by the time I finish speaking. That is just simply a fact of how fast the service is growing. Let's talk a little bit about the scale that we're operating at. And especially, this is important for those of you who may not have seen this talk before, and we'll go into the details a little bit. We have essentially one of the world's largest network. It is amazing to think that we started from just one data center just a few years ago, with over 100 data centers at this point and growing. In fact, we are accelerating the places in the world where we are putting up a data center. Why do we do that? Well, we're doing it because we want to provide the best possible experience for our customers, especially when you think about performance and latencies. And in some cases, specific rules and regulations for a country dictate that we are there in order to respect their rules and regulations. And it is amazing because if you think about how big the world is and the amount of network gear and underlying infrastructure that is required to build this, which we will go into a little bit of shortly. This chart essentially shows the growth rate that we have seen since starting the service. As you can see, it is a very impressive exponential growth kind of a chart. In fact, when we showed this last year, we were saying, you know what, we're going to repeat this again this year coming around. But, at some point, you got to figure out, are we going to slow down? In fact, this year, I am sad to report that we've finally slowed down. Of course not. We continue to grow at this crazy clip. I wanted to give you some perspective of what goes behind this sort of server growth that we experience. Remember that picture I showed you earlier around the people loading up the data centers, servers into the data center? Well, there are three things to think about. First, servers get delivered, and we have people in data centers that rack up the machines. Then they hand off to another group of people who ultimately put on additional software and do further hardware configurations before they finally hand it off to us, the engineering teams, in terms of what we call RTAG that we take to production. Well, the reason I tell you this is you notice in the middle here this sort of what looks like a slowdown. Now, to be clear, the number of servers we have isn't an exact approximation of the crazy growth we're growing, but it is a good proxy. But what really happened behind the scenes were, we had a lot of servers that landed in our data centers, but there was a bit of a logjam in terms of them pushing onwards. Think of an assembly line where things kind of slowed down a little bit. Well, as you can imagine, at the volume of servers we were dealing with, the moment they kind of figured it out and fixed it, a huge wave of servers were unleashed onto the engineering teams. We were literally hitting new records from a server throughput capacity every month talking about, wow, we broke yet another record for deploying servers production. And yet, at the same time, because we had slowed down a little bit in terms of getting to production, we had a lot of pressure coming from a senior leadership team to go faster and faster and faster. As Scotty would say, "I'm giving her all she's got, Captain." It was an incredible experience when we continued to do so. This is an interesting slide I thought I would share with you for the first time. It is a fairly significant milestone for us. Over 100 billion messages delivered in a single month. In fact, the latest numbers are even higher as we speak. Just as a way of comparison, I did a quick search. Turns out that's about the entire year's worth of mail delivered by the United States Post Office. So email has continued to grow at an insane clip, at least from our service perspective. Can I get a show of hands of folks in this room who are still thinking about moving to the cloud? Or are you all already committed to doing so? You know, fairly no number. That's about right. Well, for those of you who are considering moving to the cloud, you will no doubt be thinking, hey, there are 3 things I need to think about. What's the cost? What's the risk? Do I really trust this cloud thing? And the value you're getting, is this what I really want? Is this how it's going to improve my company's productivity? Well, here's what we really do behind the scenes. On cost, there are 2 things to think about. One is we work really closely with our Azure friends to essentially consolidate what we call hardware SKUs. When you're able to do that, we essentially become one of the world's largest buyer of hardware. And when that happens, you get to go negotiate as low as pricing as possible with our vendors, and ultimately we pass those savings on to you guys. The second factor is this constant focus on what we call COGS reduction. After we buy the hardware, we have a lot of folks who spend an amazing amount of time focusing on how do we squeeze more and more performance on the same existing hardware in order to accommodate all these new features that we're building day in, day out. And of course, our goal is to continue to push innovation while respecting all these conditions in terms of the environment we're in. We believe that by pushing the envelope for these 3 conditions, are we able to offer one of the most compelling services on the planet, given the scale that we're running at. One of the first key learnings for us in running such a large service is that everything fails at scale. In fact, the focus has shifted from predominantly where we look at root cause and understanding what's really going on. To be clear, we still do that. But when you run a service of this magnitude, the focus shifts to recovery. Every minute that we're down means somebody somewhere is not getting their email or not able to access the service. This is incredibly important when we now realize that we have banks, major parts of a government, and even parts of countries are now relying on us to be up and running. We will talk about some of the subsystems that we've built, including some of the service philosophies that drive and permeate the entire engineering organization. And even more interesting is we have to do this with the highest levels of security and compliance in order to ensure we meet the requirements of our customers. The thing I do want to point out, though, is even though you have all these subsystems, the most important thing to think about is ensuring that you are driving a very tight loop in between them. This is key. We've learned that if you let things sort of go stale for more than a week, which we'll in fact tell you a little bit later on, things break, we hit funny issues, and it's a key learning that we've also had to go apply. One of the key design principles for us is the fact that we keep 4 copies in multiple parts around the world. Why is that important? Well, it turns out this is how we go about protecting your data and ensuring a certain level of uptime. By having multiple copies, it lets us guarantee that we can deal with hardware failures, network failures, top-of-rack issues, and the occasional data center outage. In fact, in order for us to handle an entire data center in any region around the world, we actually reserve enough capacity distributed across the entire service to enable us to run at this state. One of the most amazing experience I had when I first joined the team not too long ago was every one of us gets to be an incident manager where you're responsible for the service. And my first time involved with one incident where with the single click of a button, our engineering team said, you know what? This particular part of the US is not doing well. We need to fail out. And literally within 20 minutes, without anybody really noticing around the world, we made the call, and suddenly we were running live, failed over to another part of the United States. And that was just mind-boggling from my perspective, how sort of truly amazing our capabilities are in doing so. Well, as it turned out, this is incredibly important. This is a picture taken from inside one of our data centers. I'll tell you another story. As you know, like every competitor, we run the leanest, densest, greenest data centers as we can. And what this usually means is that we will compromise on things like air conditioning. Because, it consumes the most amount of electricity and therefore cost in running data centers. And in fact, we have termed some of these data centers adiabatically cooled. Well, turned out last year, the United States had its hottest summer on record. And coupled with the usual humidity, resulted in an interesting phenomenon in some of our data centers, especially in the Midwest. As we started the summer, we saw server after server start to clock down. Essentially, the servers were hitting what I would call their maximum operating temperatures, and the only rational way for the servers to keep going was to clock down. Well, that's a huge problem for us because we were assuming that the servers run at maximum capacity. By clocking down, we essentially lost half of our available capacity in that data center. Of course, us being engineers, we thought, hey, why not just crank up the fans? That way we don't clock down. And of course, our friends in the data center were saying, no, don't do that. That's going to have a bad effect. And we're like, that's all right. We're smart. We'll figure that out. And of course, a few weeks later, they sent us this picture. And essentially what had happened was the air that we had generated was so high and so hot that it caused the walls in the room with the servers to become separated from the ceiling. Needless to say, we quickly undid that change, and we no longer ignored our data center friends. After we barely survived the summer, in this sort of failed state where we failed out of the data centers, we began working on a solution. What do? We cannot have this repeat itself next year's summer. Of course, we were also assuming that during the winter months, we'd at least be able to find some data centers somewhere, maybe in the southern hemisphere, that we could test out this in production. Of course, luck as would have it, we had a very mild winter, and therefore we didn't have enough, essentially temperature hot enough to simulate the conditions. So what do? As engineers, we were creative with our friends in data centers, and ultimately what we did was we taped cardboard to each of our server racks as a way to simulate the failed conditions. This worked perfectly because we had yet another record-breaking summer heat wave this year that we were able to run at our full capacity without needing to fail out. Let's zoom a little bit into what I call our service fabric. What you will notice is that it's made up of many loosely connected systems. Why is that important? Well, what it allows us to do is that each of the system can then independently scale on its own. This level of flexibility lets us focus on a smaller set of components while being able to rely on other parts being stable. In fact, some of our demos will go into a little bit of how some of these systems work and to give you a flavor of what it feels like. On that note, I would like to invite my friend Karim Batish, who is one of the long-running Exchange engineers, onto the stage to give us a demo of what he does in terms of troubleshooting large-scale problems. Welcome, Karim.
Thanks, Eddie. Well, I'm going to show this as a real demo by not being logged into my laptop before I start. Hi, could I see a show of hands quickly? How many of you are Exchange Server administrators or have been Exchange Server administrators one time? Awesome. And how many of you have managed mailbox servers and done things like move servers for upgrades? A good number of you. I'm a group program manager, and I'm responsible for the team that owns storage in Exchange Online, as well as in the Exchange Server product. And in many ways, I'm responsible for the administration of Exchange's online storage system, much like, I guess, many of you are. Now, as we run Exchange Online, one of the differences that might exist between on-prem and the cloud is really the scale at which we operate. As of this week, I think we crossed somewhere around 400 petabytes of user data stored in mailboxes across about 100,000 mailbox servers. So when we have to troubleshoot and figure out when things are going wrong, we've got some tools that we needed to build to sort of keep ahead of that. And as Eddie mentioned earlier, be able to quickly troubleshoot and diagnose from the problems. One of the tools behind me is the Office Service Pulse, or what we call OSP. Now, the reason I brought up migration and moving mailboxes is because we do that in the cloud quite a lot. There's a couple of reasons that we move mailboxes in the cloud, and they're pretty much the same as those for on-prem. The first is when you add new capacity. As you could see from Eddie's slide earlier, we're adding servers like it's going out of style. We're putting data centers into new countries and creating whole new regions. And as a result, we're moving user mailboxes in there. And we've invented a bunch of really interesting technology in the service that does automatic load balancing based on space, based on balancing CPU across servers, depending on peak times or where there's troughs in usage, as well as making sure that there aren't too many IO-intensive users in one place or another, or even just network load and network saturation. So we're always keeping tabs and tracks, that sort of thing. The second reason that we move mailboxes around is when we do something fundamental to Exchange that changes the way we want to store the data. Examples of that might be that we've found some amazing new way to reduce the I/O footprint of Exchange and need to change the way we write user data to disk or to the database. Another might be we've changed our search tech. A last might be we've added some security features or security functionalities a layer down. And as a result, just like we require you to do on-prem, we in the cloud will move user mailboxes around. And at a scale of 400 petabytes and growing, we really do have to stay on top of this. And there are usually order about a dozen of these projects going on at any given time. So we're continually shuffling bits around. Now, one of the things that happens with these projects is people will call me. They will call and complain and say, Kareem, my project's going slow. Why haven't you moved my mailboxes? And what we have to do is go and troubleshoot. And this is the blue badge peak that was mentioned in the description of the session. I'm going to show you things that our lawyers would never actually agree to, that hopefully you will enjoy seeing. And it's Exchange Service scale, debugging and troubleshooting. The first thing that happens when someone asks me, why is my stuff going so slow? I take a look at this. What you see here is the availability view of just one partition here, one forest, namprod 00. That's our service dog food partition where we run Exchange bits. Oops. We'll just keep it on that DAG. We run the Exchange service bits before they roll out to broader production in the rest of the world. That's the place we turn things on, try things out before anything happens. More broadly. And it is why you see a slightly bumpy bit of availability. Usually worldwide, it's a pretty smooth line unless something is going really wrong. There's a couple of things that you'll see there. The red alert line, Eddie will talk about later when he describes red alerts, but it's an amalgam of the availability across protocols. It lets us find problems even before individual protocols will fail. And you'll see there's an Outlook web app, ActiveSync, and Outlook connectivity to the server, and that is grouped monitoring of availability across each one of those protocols, both synthetic probes that let us see are these endpoints working, are basic transactions happening, and synthetic transactions where we look at user latency and user errors and roll those up so that we can actually tell if users are having problems that our synthetic or artificial probes might not see. Now, in this case, if I'm trying to figure out why things are going slowly, this view doesn't really help me. There aren't any major incidents, and these projects that we do, these big moves, these big load balancing projects, we run them in a discretionary sense. They don't take priority over service health, and they don't take priority over user load, which would be represented here, and they don't take priority over user onboarding projects. So if any of those things are going on, I should be able to see it and give a quick answer. So availability is fine. What I can then do is go take a look at our balancing heat map. Now this view gives me a kind of a bird's eye view of the entire Exchange Online service. I can guess based on the columns how many databases are, relatively speaking, across the service and how full any of them are. There's a couple spots that are red, but in general this view looks pretty clean. We call it the Perry scheme after Perry Clark, our fearless leader, because green is good and green is fairly full, but as far as we're concerned, green is good. So we keep looking at that chart usually every day to say, are things going well? Is the balancing service doing its job? And again, that NAMPROD00 partition, it's purple. Purple is really good. So there really aren't any big imbalances there. Now, when things start getting interesting is when I start to look at throughput. And what we do, again, is across our service, we have to look at aggregate data and aggregate throughput, which is really the most interesting thing to figure out why hundreds of terabytes of data are moving slower than expected. And there's a couple things there that are interesting. Now, some of this is simulated in not exact view, but you'll see that in the top middle, that the number of servers or DAGs, capacity units, that have active requests has actually been dropping off for a few days, which is problematic and indicative that there's something lower level that's an issue. And the next thing I would check is to say, well, how much data has been moving in and out of the service? And as I look, there's a bunch of data moving in. I'll give you an idea of what a data point looks like here. Eventually, there you go. So you can see there's actually about 10 projects that are tracked in this partition. And this is an idea of how many gigabytes have actually been flowing through each one of these projects that's being tracked by the orchestration of our system. And we can see that load balancing is moved. A few days ago it was moving about 700 gigs in a day. And as we get over here to the 25th, actually very few. And I'll say this isn't a simulated problem. This is a real issue that we have been debugging over the last few days. The last thing I'll check before I try to dig into the service is the set of failures in this particular forest. And again, what we do is collate all of the MRS move reports, the same ones that you can look at on-prem, and then categorize the content within them to make sure that we know what's going on and how the service might be reacting and failing. And again, if I'm trying to figure out why something's going slow, I look at fatal failures, 15 failures, not too many. But it looks like we're seeing thousands of transient failures in the service, which tells me in that service dog food environment that something is up. Now, this is the part that's kind of fun. In the OSP view, one of the common things we do as engineers is drill down to look at capacity. We take a look at the set of services, the set of DAGs. Each one of our DAGs is 16 nodes. We load thousands of mailboxes, as you can see here, on each one of the DAGs. And we basically track CPU, I/O, replication, network, memory, free space. This is really a snapshot into what you might see in perfmon, but at scale, running perfmon against 100,000 servers really doesn't work great. So we've got a set of tools that plug into a massive archive of perfmon data that is continually running against the service so we can see a live view of what's going on. In our service dog food environment, what we have done is set aside one of the capacity units, this one over here, NAMPROD00DG5. And it really should be getting megabytes a second of replication traffic. That means if we're pushing data in, as an engineer, I would expect to see megs of data going in a second there, and really there aren't. So what I can do at this point is drill into the DAG and look at what's going on. Now, one thing we do is we use failing servers out, failing servers in to upgrade the capacity. And some of the servers are actually out of rotation at this time interval as they're being upgraded, but the other servers should be able to handle capacity just fine. And there's a couple of things that are highlighted here that are a little bit odd. You can see that there's a couple of servers that are doing over a megasecond, but this server that's chewing up a lot of CPU is in fact not moving very much data. And that's really a concern. So I can track, over time intervals at the 85th percentile, this server is mostly busy running at 80% CPU. And, as a concerned engineer, I'm going to need to really go and dig in and take a look at that server and see what's going on. Now, as Eddie mentioned, I've been in the Exchange team for a really long time, and I'm pretty old-fashioned how I go debug. A person working on my team who doesn't necessarily need to connect to every server might, instead of going and looking at that server, would essentially aggregate a bunch of process-level information. But I'd rather go look one server at a time. So we've built a tool called Measure Performance, which lets us dig into each machine or groups of machines, or in fact DAGs, to see what's going on. Now, as this tool is running, and this is live against the Exchange Online environment, so cross our fingers, you'll see a couple things. You can see that it's real hardware. You can guess from the SKU name, if I can scroll back up there. You can guess from the SKU name that you saw up above. One more second here. Whoop. Like scrolling. That it actually is real hardware that you yourself can go and buy. Sorry, I've lost my mouse. Let's do that one more time. We've got a very slow session here, so you'll have to forgive me, folks. Why don't I flip to the picture to give you an idea, if I can. Here, what I'll do is I'll flip to a picture while that thing is refreshing. Right here. So, as we render the picture very slowly. Very, very slowly. What you will see is essentially a process, a dump of all of the processes running on the box. Now, there's some other information as well that is interesting to the session or to debug the server. But the actual problem, you'll forgive me for, again, getting stuck. Let me just close this and show you from here. It should be a little bit faster. All right, hooray. All right, so what you see here is that server. You can actually see the SKU that's running on. We said we wouldn't name the manufacturers, right? But it's a DL380 Gen 9 with 24 cores and 192 gigs of RAM. And you can see that sample again where CPU is approximating 70 at the time of the snapshot. And you see as well a list of processes. Now, if you've administered an Exchange 2013 server or later, you'll see that these are the exact same process names of services that run in the on-prem instance. In fact, you don't see any of our orchestration code really running there except for perhaps the big data loader in the end, which is what helps us upload a bunch of the telemetry. There's a bunch of things that you can actually see here. High CPU, number of databases that are mounted on the server, requests a second, the number of reads a second on C drive, and then a stack rank list of processes by CPU. Now, percent CPU, if you're familiar with looking at perfmon, you get 100% per core. And the replication service, which is the same MRS migration service that runs on-prem, also responsible for load balancing, is actually taking up nearly 7 cores of CPU. And there's something else that's moderately alarming here, which is that there is a large amount of that time being spent in contention. And as always with engineers, it's a funny story. As the migration team, we added logging to understand better understand the performance issues in the service. And it is, in fact, that logging that caused contention in this case. And the logging for performance is actually what caused the perf slowdown of migration. Normally an investigation like this, barring the very slow connection to the data center, generally would take a few minutes. And the dogfood environment lets us find these kinds of bugs before they hit scale, before they hit production, and get to servers that would be yours or hosting your data or your users. With that, thank you. I'll head back to you, Eddie.
Thank you, Kareem. Hopefully you had a sense of kind of the world we live in, and of course, machines that don't behave. We know quite a little bit about that. All right, let's spend some time talking about monitoring, which is a key area of how we run our services at scale. This is a slide that if you were an engineer in the Exchange team, you would be very familiar with. We look at this probably every month, and it represents a really important metric. What it tracks is essentially the number of red alerts, which we'll talk about later, that are generated on a monthly basis. Well, why is this important? Every time we have a red alert, essentially the engineer gets paged. And so our goal, obviously, is to minimize the number of red alerts we get in the service while ensuring we don't miss any incident. We also wanted to plot the growth of the service as we are running our monitoring system. And as you can see, while the green line, which represents the server number count, continues to grow, we are able to keep the number of red alerts somewhere between 1,000 and 2,000. To be clear, this is an incredibly large and difficult problem that the monitoring team drives on a daily basis in order to ensure we don't simply just keep getting overwhelmed with red alerts. Monitoring is just a start. It is what you do with it that matters more than anything else. We'll talk about three things in a little bit. The first is the signals. What do you do with it? What can you make sense of it? The insight that hopefully you can derive from understanding the signals. And then the work you do once you have that insight in order to help you run the service. At the heart of our monitoring system, we have this thing called the Data Insight Engine. It was built for massive scale. As you can see, it's probably even higher than 500 million transactions per hour at this point. Not only that, we are constantly adding and evolving the capability, things like new signal ingestion pipes, new data streams. In fact, the technology we used to build this engine has evolved over time. We started originally with a pure Microsoft set of technologies, but recently we've started to incorporate other open source technologies like Cassandra, which we announced last year, in order to deal with data storage and computation at scale. We will also talk about one of the evolutions of the monitoring system later on in something we internally call the customer fabric. One of the key systems that we rely heavily on is this thing called outside-in monitoring. Essentially, every 5 minutes all over the world, we simulate a series of basic transactions that tells us if the service is running or not. This creates a baseline that we will then use later on, which I'll explain. Of course, you have to imagine that so much traffic assumes a reasonably high working network, which we saw earlier, since we are global. This is a picture of our network cabling sort of hanging out. Turns out there was a massive landslide somewhere due to a storm, somewhere in the middle of the US, that essentially took out one of our primary network trunks. We were aware of this when suddenly all our red alerts start firing because we essentially saturated all our backup links. And it wasn't until we realized that, we lost a major trunk. In fact, it took several days, as based on this aerial photo, for us to even get to the location of the fiber cut in order to repair it. Here's another picture of the damage caused by Mother Nature. And finally, I'll leave you with this last picture of what are the things that we have to deal with as we run a global service. Kareem mentioned about the passive monitors. It is also yet another key signal we use in order to understand what's going on with the service. What we do is we go record a series of user-generated traffic and signals. After, of course, we've stripped out all the PII data. But we look for things like user login. Where are they logging in from? Are they getting errors? What kind of OS are they running? What kind of browser are they running? What we do with this is that we join them, and we'll show you later on what we do with it. But the key is that this is all user-generated traffic. It's all after the fact, and is an important facet of how we think about monitoring. You may be thinking, wow, you just generated millions and millions of outside-in monitors and passive monitors, and what are you going to do with all that data? Aren't you going to be overwhelmed? In fact, with most what I would call threshold-based monitoring, yes, we would absolutely be overwhelmed, because everything assumes that every signal is of high fidelity and super accurate. Well, this is where the team had a very interesting idea. They said, hey, rather than relying on each signal being good or bad, what if you took all of them and evaluated them together? The idea is that if many signals say something is wrong, well, duh, it must be something is actually wrong, as opposed to one or two or a few number of them where it could literally just be noise. And of course, this also takes away the burden of each signal being super accurate, which is a common problem that a lot of monitoring systems try to deal with. As it turns out, this approach fundamentally changed the game of monitoring for us in a few ways. The first is it dramatically reduced from millions to essentially thousands the amount of signals we have to go pay attention to. Second, it no longer needed us to have individual fidelity of each signal. And third, it dramatically increased the confidence that we were able to see that something was wrong. In fact, we call this a red alert. You have seen this earlier when I showed you that we generate somewhere between 1,000 to 2,000 red alerts. This is sort of the result of our monitoring system telling us something is wrong. Well, what do you do with all these red alerts? Well, this is what we do. We actually take them all, and then we plot them against time and partitions in a service. In this case, you probably cannot read it, but each row represents a forest in the service. And when we see issues that arise from a single column or a single day, what it usually tells us is something at the lower levels, such as networking, or in some cases, Active Directory, is down. This lets us quickly work with our partner teams to get it working as soon as possible. And of course, when you see something that goes just at a particular forest, it means something is unique and isolated to that area. And again, it lets us quickly understand what changes do we do in that forest to quickly get it up and running. And of course, every so often we see this chart and we're still not exactly sure what it's trying to tell us. Let's talk a little bit about Customer Fabric. Remember, we started this monitoring system, what we call the Service Fabric. It was amazing in telling us everything we needed to know about machines, databases, forests, pretty much any physical object in the service we had deep insight to. But it was really hard to tell, hey, I am affected. Can you tell me whether my customer, my tenant is affected? And no, it was very difficult for us to do so. With the Customer Fabric, what we did was to leverage all the learnings we had in terms of building Service Fabric, but apply them to a new dimension, something that we can look at on a per customer basis. And again, we were very sensitive about the data. We made sure all the PI data were stripped away. But in a nutshell, this lets us tell individual customers at a tenant level whether they were perhaps suffering from an outage, even though our service was essentially saying everything was good. And on that note, I would like to welcome Pavani to the stage, who will give you a little bit of insight and demonstration of the new Customer Fabric.
No? Okay, there you go. Hello, everyone. My name is Pavani. I am a program manager on the Office 365 Customer Fabric team. I'd like to spend the next couple of minutes walking you through two tools that we use internally. The first one I want to talk about is called the Red Alert Drop Zone that's powered by the SED Service Fabric. The second tool is a more customer-centric tool called Lynx that's powered by the Customer Fabric. Then I'd like to conclude by touching upon what all this means for you, what's in it for you. So let's get started. So what you see over here in front of you is the tool called the Red Alert Drop Zone. So you've heard a bit about our monitoring systems, red alerts, et cetera, et cetera. So when these systems actually detect a problem with our service, we fire an alert. So when this engineer gets paged, the first thing he does is actually opens up this tool. The goal of the Red Alert Drop Zone is to scan through all the data in the service fabric and bubble up the most relevant sets of insights that actually empower the engineer to go fix that problem quickly. So over here on the left, you see the scope that's impacted in this specific alert. So it talks about DAG, region, forest, so on and so forth. You also see the red alert availability lines over time. We also bubble up machine level information. So it's not just what the machine name is, but we tell you what the CPU is pegged at, what build is running, how many user mailboxes are actually mounted on that database, and so on and so forth. Again, all with the goal of getting the engineer up and running really, really quickly. So let's assume this engineer of ours goes and checks in that fix, and it gets deployed, and the service is back up and running. So what happens then? Our job is not done yet. What we then do is switch gears and use a tool called Lynx. Now, just as an aside, Lynx is a type of wildcat, like a tiger, lion, etc. And mythology has attributed several supernatural qualities to this creature, including that of clairvoyance and just deep insight. And so we naturally had to name this tool Lynx. Anyway, Lynx is basically an on-demand tool that does a continuous assessment of every single user in Exchange. So what you see over here is a dashboard that we've pulled up for Microsoft. So you see you have about 120,000 users who've logged in recently. The chart below that shows you the unique user count over time. So you notice these 5 peaks correspond to the 5 work days. The sort of little bumps correspond to the weekends. And just eyeballing the chart, you know that something went wrong over here. You expect a 5th work day. And our first instinct was, let's go check the service. But it turns out that was the 5th of September, and all Microsoft employees decided to suitably not log in and check their emails on that day. So let's move on just for a little bit. You see this bar chart over here. That talks to all the incidents that have occurred in the recent past. And now for the very first time, we're actually able to map an incident down to our customer level. And by that I mean both down to the tenant level and even to the individual user level. We have a lot more to show at our service health dashboard session tomorrow, so come check out the latest and greatest on that front. So over here you see the incidents that have actually impacted Microsoft, when they've occurred, how long they've taken, et cetera, et cetera. So let's switch gears for a little bit, and let's assume the service is running just fine. Everything's peachy, the service is humming along. So this is our steady state. So what is Lynx doing in the meanwhile? In the background, Lynx is continuously assessing every single user. So even if the service availability is up at 100, Lynx is revving in the background. And what we're doing here is gleaning a bunch of insights about our customers. So an example over here, this chart shows you a set of client-side errors that we actually gather. So we'll walk through an example over here. Let's pick on the dumpster operation exception, and some of you may be able to relate to this. This actually is engineering speak for users hitting mailbox storage limits. Another one that you would resonate to is the invalid license exception. We all know license management is messy, and we feel the pain too. That points to a bunch of users possibly logging in with invalid licenses, expired licenses, etc. So aside from errors and service health, Lynx is also trying to build this holistic, this 360-degree view of the customer. So we also are trying to understand what devices you guys like, what apps you use, what the status of your subscriptions is. So this is a view that shows us, what the active subscriptions are, when they're going to expire. That orange bar marks the expiration window. So you've seen a bunch of stuff on screen here. And now I'd like to just tie it all together and clarify the impact all of this makes to you. So we started with the red alert drop zone. The goal there is to reduce that time to resolve the incident, so service availability is back up to at least 3 nines. Then we talked about Lynx that helps us actually validate your true experience. Then we talked about service impacts. It's now powering the new and improved service health dashboard that gives you better service insights. And last but not least, I showed you a bunch of steady state insights. And I'd like to give you a quick peek into what this can do for you. Again, this is a new offering that called Everyday Insights for the tenant admins. Again, this is powered by the Customer Fabric. The goal here is to gather all these insights that we're actually computing and serve it back to the admin. We want to empower the admin with a set of insights that truly let them get the most out of Office 365, ultimately to save time, to save money, and just be more productive. So you will be now be able to tie the story together, because some of the insights that we want to show over here are, say 3 users in your organization are hitting mailbox storage limits, or that you have a couple of users hitting license problems. And last but not least, say you're down to 20 available Exchange licenses. And so we're not just going to throw this at you. What we want to do is augment this with rich data. Of course, we can point you to where you can go and buy more licenses, but we want to do more than that. We want to actually hand you the sets of users, say, who've never used the Exchange service, and you can possibly reassign licenses and just save money. With that, I'd like to hand the stage back to Eddie to talk more about our service. Thanks.
Thank you, Bobby. All right. We will move on to what I call the brains of our service management, something we affectionately call central admin. Of course, we always joke that we are turning the robots as dictated by this picture. Remember that the service is huge. We have hundreds of thousands of servers with petabytes of user data that we're responsible for, running over an entire global network. As a result, we built a special purpose system that ensures that all actions that are applied to the service are done so in a safe manner. We do this by ensuring that the orchestration of these actions are themselves robust, along with the workflow themselves. In fact, everything is forced to become code, which then allows us to go test it, verify it, and also validate it with other workflows, all within central place called central admin. This is how we protect the service, the user data, and essentially prevent accidents that our engineers may accidentally do in terms of harming the service. Of course, as like I said in my earlier comment, what most engineers don't realize is there's a greater central authority at play. Central admin itself is also a major service of its own right. As a result, we also run it like any other production service. It means it has its own SLA, metrics, lifecycle management that we track on a regular basis. We also look for poorly written workflows, fix them, or remove them from the service. Let's talk about something that is dear to my heart, as my team is directly responsible for this. One of the most complex and frequently run workflow in the service is deployment. Because deployment essentially brings thousands of changes per week to the service, we needed a way to ensure that we could protect the service while we were updating it. What we do is create multiple partitions in the service that we call rings. let's talk about ring 0 and ring 1. This is where me and the entire Exchange team have our mailboxes hosted. We believe that it is the best way, with a term called dogfooding, for us to directly experience all the changes that we put on ourselves. It is incredibly important. We treat it like production, but it also enables us to move very, very fast. In fact, you would have heard earlier, we go, in fact, multiple times a day, so that if we do something wrong, we can quickly apply a new fix by simply deploying it to ring 0 and ring 1. Ring 2 represents the entire Microsoft population. We deploy roughly once a week, and we coordinate with our own internal IT operations to ensure that they are aware that we're deploying, and that if they see anything, to let us know as quickly as possible. Essentially, Microsoft is our own last line of defense before we roll out a change to the rest of production. And of course, we're also a little more careful with MSIT, since blowing up Satya's mailbox is probably a fireable offense. Ring 3 is what we call SIP ring. We also call it a slice in production. It is a small but reasonably large part of production, which we also go after we completed our MSIT deployment. We will rotate this if we end up missing a regression that had somehow escaped MSIT. And so we want to ensure that we're not hurting customers in an unfair way. And last but not least, ring 4 represents the rest of our production. And it goes much slower, just like SIP, only when we believe we're safe to go do so. It does not mean we always catch everything. And we'll talk a little bit about what we do when we do in fact have regressions. One of the key things I do want to talk about is how we manage our hardware. In fact, if you're used to running services, you will know that typically you see about a 10 to 15% hardware failure rate. When you have hundreds of thousands of servers, that's a lot of hardware, especially given the different kind of problems that you may run into. And in fact, this chart shows you what the #1 breakdown and what the key major areas that require fixing. As you can see, if you look at hard disk drives and power supplies and fans, essentially things that move break often. In fact, if you remember earlier, we talked about the log jam that we saw in getting servers up and running. Well, it turns out that hard drives are kind of like loaves of bread. If you leave them out for too long, they get stale and get moldy. And in fact, that's what happened, was the servers had been in dock for so long that by the time we were ready to stand them up, the drives were failing at an incredibly high rate, and it further caused more log jams onto the service. That is a lot of hardware issues to go resolve. So what do? Well, we created a specialized CA workflow that we call RepairBox. It is the reason why we actually don't see the 10 to 15% of the failure rates. In fact, we consistently see only about 1% that our engineering team has to deal with. This particular workflow basically goes around the world and checks for machines, tests them, and maybe proactively pull them out of rotation in order to avoid them becoming a roadblock when deployment is about to begin. In fact, we have done work where we've tied deployment workflows to RepairBox so that they work both hand in hand in terms of isolating, identifying bad machines, and taking that out of rotation. And no, this is not a bunch of monkeys that we feed with bananas that keeps running around the data center fixing things. On that note, I would like to welcome Mike Swafford to talk a little bit about what he does for the service. Thank you, Mike. Thank you.
Let's get going here. So I'm going to talk a little bit about what on-call is like. All right, the computer cooperates with me. All right. Here we go. All right, so you've seen OSP. You've seen some of the other tools that we use for on-call, and I'm going to talk about a specific type of on-call rotation, and that is the incident manager. Most on-call engineers spend their time working in the components that they own, the code that they've written. Makes a lot of sense. If you write it, you know how to fix it. Well, we have another rotation called the incident manager, which are typically management, people who've been around a while, who are pretty good at putting out fires, or at the very least, figuring out who to call in the middle of the night. So I thought it'd be interesting to talk about my last on-call rotation, which was last month. And I'll do a very condensed version of it. We can't possibly in 5 minutes go through debugging the entire service, but it'll give you a flavor for the tools that we use and what actually happened with a specific incident. So to set the stage, this was the second week in August. It was right at the end of the 2 weeks of summer that we have in Seattle. So not coincidentally, we had a deployment freeze for 2 weeks because we wanted to make sure that we got as much sun as we could, give the deployment team a little bit time off. And I thought that this would be great. We weren't putting new builds out. Nothing was primed going through the rings. We weren't going to have a lot of churn going on, and I would have a nice, easy week. No such luck. It turns out I came on call Monday morning, and almost immediately, I got an alert. So this is what an alert looks like. It's a mail with a lot of information, big scary red text. If you scroll down, you see that it tells you what's going on, tells you what the probes are saying, and it's for a very small set, just a DAG, telling you what's going on with that DAG. Tells you which protocols are failing, tells you which component is broken. It's Kareem's component, so he broke something. And what that actually really means is that no one can talk to the server, or not no one can talk to the server, but 5% of the time the requests are failing. And so we want to understand why. It tells you which servers are failing, and it turns out there's one server that is failing much more than any of the other servers, so that's probably where the problem is. And it tells you what it'd like to do. It'd like to restart that back-end server because it thinks that will fix that issue. And then it's so helpful that it goes on to tell you 3 times why it didn't actually go through with that auto restart action and decided to call you instead to investigate. So if you look at the error says global throttling, global limit for auto recovery by red alert per hour. That's really odd. I hadn't seen that before. That suggests that we're doing a lot of reboots. And we like to have the systems automatically recover. But on the flip side, we don't want to have them automatically recover, reboot every machine in the entire service at once and cause the lights to dim on the eastern seaboard. So we decided to put some hard limits in place to make sure that we didn't reboot too many machines. We have a report that tells us what's going on. So here's the generic report. And let's drill in and see what's going on with that day. And this is the report from that day. As you can see, this green line here is the number of reboots per day. Kind of goes up and down, up and down. And you see here, this is right when the deployment freeze, when we were a week into the deployment freeze. So it was about the time that we would start rebooting machines, rebuilding machines. And we see the reboots creeping up. Now, that's very interesting. So over the course of a week, it started creeping up. And then you can see this is exactly when I went on call, and then it just shot right up. So we have a huge number of reboots going on. Well, that's also very interesting. So let's see if we can figure out what's going on with all of these reboots. All right. I have to go over here. So Kareem showed you earlier one of these tools that has performance information in it. And I'm going to show you a picture of that tool, since it's kind of hard to go back in time. So this is using the same data that Kareem showed you, except it's a perfmon style view. And the way to think of it is it's like perfmon, except it's perfmon with a DVR for all the machines in the service. So you can go back in time at a specific point in time and take a look at what's happening. So I've helpfully annotated this. So I'm looking at a couple things here. One, I'm looking at these massive spikes. The bolded thing are the number of threads in the replication process. So that means that something happened to cause it to have to spin up a bunch of threads. And really the only thing that can cause that is a massive latency in I/O. Well, if we also look at this purple line, the purple line is kernel CPU. The kernel CPU spiked massively at the same time. So that's also interesting. That suggests that the kernel was doing something that was blocking up I/O and causing latency. And if you look at this blue line that goes ever increasing up, that's the number of seconds that the server has been up. And you can see that this has been up about 12 days. So that's pretty interesting. So what we probably want to do is we probably want to take a step further and try to debug what's going on. Let's see if I can, my mousing skills are, aha. Let's go to the backup screenshot. So I'll show you a screenshot of what we found by investigating this. So if we look at what's going on, we will see what is the kernel up to, and that will give us an idea of what's actually going on. So here's the call stack that we found by grabbing an ETW trace and looking at it in Windows Performance Analyzer. Well, it tells us what the kernel's doing, and we see something interesting. We see that it's doing extend paging files. And so what this means is it's trying to grow the page file on the system drive. This is causing NTFS to convoy and hold up all of the I/O for all of the rest of the applications, even on other drives. Well, that's very interesting. Why is it doing that? And why is it even growing the page file? So I have another screenshot that will show us what the configuration is on this particular machine. So here's a screenshot. I'm sure you've seen this dialog before. So it says that have a custom size for the page file. The minimum is set to the maximum. And in Windows speak, that really means your page file should be set, should be constant. But if I look at the current size of the page file, it's significantly below the size that we set it to. That's really interesting. That shouldn't happen. If we've set a fixed page file, it shouldn't be growing, and it certainly shouldn't be smaller than what it actually is. So since we all work at Microsoft and we're all engineers, and we do a pretty good job of looking at things ourselves, we can actually just go ask the Windows dev, what's going on? So we called them up and we said, what's going on? We don't understand this. And there was a lot of back and forth, a lot of discussions, but it ended like many tech support calls do, where they said, did you reboot the machine? Does rebooting the machine solve the problem? Well, it turns out that rebooting the machine does solve the problem because this is a piece of configuration that requires a reboot. And in our infinite wisdom, we had optimized something at some point in time, moved this piece of configuration after the last reboot. And so these machines had not been rebooted for a week and a half after setup. They had their default page file that had to grow, and after they were up for a bit of time, they grew enough, the page file needed to grow enough that they hit this I/O contention problem, which caused these little hiccups. Well, now that we knew what the problem was, the fix is pretty straightforward. Well, first thing we do is we up the limit on the auto reboots. We up the global limits, but we don't up the per DAG limits. We don't want the databases flopping around on the DAGs, but we do want to have more reboots happen globally so that people aren't paged to go manually reboot machines. Then the next thing we do is we move the configuration setting before the reboot. And so the final thing to look at is a picture of what it looks like now. So let's go pull up the run a report. And it's going to wait. Let's see how happy it is with these results. All right, here we go. So this is a live result. Let's hear the reboots. Here's where I went on call. And this is when I went off call. And all the reboots were done. And the next guy, who happened to be Kareem, had a nice, easy week and didn't have to deal with this particular problem. So that's a very condensed version of what it's like in a week of an incident manager. It took a little bit longer than 5 minutes, and much like this demo, it was really fueled by caffeine and adrenaline rather than just 5 quick minutes of poking around on a computer. And with that, I'll turn it back to Eddie so he can wrap things up.
Thank you, Mike. On that note, we're going to go through a new topic. So far, we've talked about how we run the service and at scale. But what I'm going to talk a little bit about is how do we improve the product, the service itself, through additional systems and processes. This is a super important slide. This is something that is drilled into every engineer from the moment they start boot camp at our team. It is what we refer to as a service culture. It enables us to focus on what's important and to ensure we're constantly improving things over time. In fact, we hold what we call a weekly service review that focuses on the previous week's incidents, the key learnings, and then apply them as quickly as possible. One of the more important reviews we also do with our corporate vice presidents every month is this thing called the monthly service review. They remind us what is the bar and how we are supposed to work. And of course, they're constantly raising the bar on us. And if you may recall from the previous talks, Perry Clark is our corporate vice president. He is notorious for having perfect memory. He will remember when you've made the same mistake twice. He is someone we deeply admire and fear at the same time. And this is a picture of him. So how do we improve the product itself? Our service is made up of millions of lines of code. It is incredibly complex. It is even larger than the service fabric itself. While we could do inspections of code, what we really do is let the service guide us. And what I mean by that is the regressions. As you recall earlier, we have this thing called rings, and we're trying to find as many regressions as we can as early as possible. And every time we have a regression, we want to learn as much as we can in order to improve our product, including and as well as processes. So there are two key parts that I will talk about. The first is the engineer. We focus on how did the regression get into the system. We have multiple systems that essentially measure things like code coverage, performance, security, and other code-related health checks. All this feeds back into the engineer directly in the place where they write code, typically inside Visual Studio, in the form of hints and suggestions directly as they're writing. This enables us to make sure that every time we hit a regression, we are making every engineer smarter and smarter by baking that learning into their environment. In addition, we also have a set of loosely connected systems that we refer to as the engineering system. One of them actually is responsible for running the hundreds of thousands of tests pretty much all the time on the code before it even gets to production. So every time we see a regression, we look for gaps in our tests and we fill them. One of the running jokes we have is we often tell engineers, Yoda is helping you. One of the other ways we help to improve the service is, in some cases, we run what we call war game exercises or monthly drills. We have a team called the Red Team. What their job is to essentially look for vulnerabilities in the service. They don't tell anybody they're doing this. Their job is, in fact, to not tell anyone. Of course, they do this with a very clear set of rules of engagements. No destructive testing, focus only on Microsoft. In fact, recently, one of their team members managed to find a new security hole inside one of Kareem's areas and essentially took one of the keys and made one of our corporate vice presidents embarrassed. Needless to say, Kareem was not impressed. We also offer this bug bounty program, which some of you may be aware of, where we essentially let others outside of the service help us find additional vulnerabilities. We have such a massive surface area that all eyes and any more hands are going to be helpful. We also have a blue team that works to find intruders, look at data, find new ways to detect such intrusion, and to protect the service. We will then occasionally simulate drills with and without each other as a way to invest in improving our process. We have a series of talks in the rest of the session at Ignite that focuses on security. I highly invite you to go check them out. Sarah Manning Dawson is the GPM, who's a peer of mine, and she's heading up a few of those talks. You may have noticed, hey, there's another service provider that does kind of something similar. In fact, for those who are familiar with it, they ended up calling their work Chaos Monkey. Essentially, we have our own version. All right. On that note, I hope everyone has enjoyed the talk. It has been a tremendous pleasure for me and my team to come here to talk to you about the work we do. We look forward to any and all feedback, as well as any questions you may have. And, one last thing before we go on. Please visit the Exchange booth. We're looking for customers who sign up for our TAP programs. On that note, thank you very much.